So 28th is a very good question actually. 28th definitely is a very good question actually. So make sure that you do this question right now. This is a question from Pathfinder. You are well aware of this. It's a question from Pathfinder. This is from Pathfinder. Right. Yeah, proceed. Read the question carefully, everyone. Say, I will complete maximum questions today only. At the maximum, I will cover all. The maximum, I will cover all. Read the question. A light, rigid pipe means pipe do not have any mass. Pipe is massless. It is the first observation which you need to consider. Right. Next, what else is there? Tell me. ఇంకా ఉన్నాయి కొన్ని క్వశ్చన్స్ మనం చూడాలి ఫాస్ట్ గా చూడాలి ఇంకా చాలా ఓకే లైట్ వాట్ బెస్ట్ వీ కెన్ డూ వీ విల్ ట్రై టు డూ టుడే రైట్ now rigid right pipe is suspended with the help of two inextensible vertical threads. You can see the threads over here. Inside the pipe, two balls, one of mass m, the other is of mass 2m, can slide without friction. Initially, the pipe is horizontal and the balls stay equidistant from each other and from the ends of the pipe as shown. How many times will the tension force in the thread A change immediately after the thread B is cut? First, try to please understand what is the initial situation. If you take up the initial situation, for example, you have M mass, you have 2M mass. I'm taking the initial situation. Tension at A, tension at B, right? Tension at A and tension at B. That's the picture. Right. See, anyway, I need to pick some 2 points. Already AB they have used. We will use a PQ as the ends. Please try to understand. They are equidistant. That's what they have given. So we will take this distance as the thing mentioned. So we will take L, L, L. Right. Now we need to apply about talk about Q initially. That gives me tension at A. Tension at A times 3L. That is the clockwise torque. Whereas the other torques, mg times 2L, 2mg times L. So what you had initially, the tension at A is 4mg by 3. Actually, this concept will come 50% next week. 50% is the present week. But that is not the criteria now. Right. After B is cut. After B is cut. Right. The moment B is cut, what situation you have is This is the pipe they're speaking about. And the tension now is different. Let that be T final. T final. And here is, see, on the rod, reaction of, you cannot take straight away mg now. On the pipe, N1 and En2. This is what I'm assuming. Suppose if I am wrong, negative sign indicates that my direct sense of direction is wrong. Okay. Now what happens is that TF plus N2 is N1. Clear? We will take that this as equation 1. Remember, this is a light rod. You have drawn the free body diagrams of the rod. Right? And one more important point is, if you take the torques about this point, it's a light rod. It is a light rod. Otherwise, I will give you another option. We want tension actually. It's a light rod. So I'll take up about this point torque. We will call this point as some C and this point as some T. Net torque about C is equal to 0. So what is that you are getting now is T final into L is equal to N2 into L. So clearly T final is N2. Right. Done. Done. Now let us try to understand the free body diagram. This is a free body diagram of light pipe. Now I am drawing the free body diagram of masses after the string is cut, after B is cut. Right. See, please try to understand. Suppose if there is no A, the entire system will free fall. But there is connection A, which means the thread will prevent, thread A will prevent, prevent what? They will prevent point P to move down, and will be thought when the thought and tension non-zero. Actually, I told you this will become next week concept actually. About this point, rotation takes place. Of course, you can write this as your choice. On the mass mg, on the mass n1, on the mass 2mg plus n2. I think you convinced it. This is the free body diagram of masses. This is the free body diagram of the light pipe. Therefore, you will take up the situation. Individually, you will work out. Like, first of all, you take mg minus n1 by m. That's the acceleration of this point. And the entire thing divided by L gives the angular acceleration of this point. And this should be same as the other point is N2 plus 2mg by 2m. Remember, this is acceleration of this point divided by 2L, because angular acceleration is the same. That's what I told you. So by solving all these things, you have N2, you have N1. By solving all this, you will get a condition. From this, you will get a condition. From this, you will get a condition that 2mg is equal to, this mm cancel, L, this is 4 actually. 4mg minus 4n1 is n2 plus 2mg. So therefore, 2mg is 4n1 plus n2. N2. Okay. And TF is N2. From this, you can write 2N2 is N1 again. So N1 is 2N2 actually. 8N2 plus N2. This is a 9N2 is a 2mg. Right or not, boys? Therefore, N2 is 2mg by 9. And T final is 2mg by 9. Initially, it is 4mg by 3, 12mg by 9. Now it is 2mg by 9. So you want just a ratio, T final by T initial. So accordingly, you choose here, right? Any doubts till this point? Right. See, particularly for girls students, I know maybe today is some auspicious day for you. It is a process for us for this year. Okay, give me 2 years, some compromise for 2 years. LOCU బెటర్మెంట్. ఇప్పుడు మీరు ఏం చేస్తారు? మీరు ఆ, బావిలో, బావి ఐడియా ఉందా మీకు? వెల్ ఐడియా ఉందా? అందులో బకెట్లో నీళ్లు పోసి నీళ్ళు ఇట్ట 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 తాగుతుంటారు, ఏం పర్లేదు ఎన్ని. నువ్వు ఆల్మోస్ట్ చేద్దాకా వచ్చే టైంకి ఒకసారి వదిలేస్తే ఏమవుతుంది? చాలా కిందకి వెళ్ళిపోతుంది. మళ్ళీ బిగినింగ్ నుంచి లాగాలి. కంటిన్యూస్ ప్రాసెస్ కాదు ఇదేమి మీకు. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ సమ్ టైమ్స్ ఆగస్ట్ 15th ఇది కలిసి వచ్చింది అనుకోండి, నేను అసలు అప్పుడు వదిలేసాను పిల్లల్ని. అసలు చాలా చేయాల్సి ఉన్నాయి క్వశ్చన్స్. చూడండి మీరు. నేను ఒక సబ్జెక్ట్లో చెప్తున్నాను, ఫిజిక్స్లో. అదర్ సబ్జెక్ట్స్ ఆల్సో యూ విల్ హ్యావ్ సమ్ కంటెంట్స్. సో ఐ నో, నాకు హ్యూమన్, నా ఫీలింగ్స్ నాకు తెలుస్తున్నాయి, కానీ నేను ఇక్కడ కోచ్లానే ఉండాలి. రైట్, రైట్. నెక్స్ట్ ఇవన్నీ చెప్తాను నేను. ఈజీ క్వశ్చన్స్ ఫస్ట్ చెప్పి, అసలు చేయని క్వశ్చన్స్ ఫస్ట్ చెప్పి, చేసిన ఒకవేళ అవసరం అయితే వీ కెన్ డిస్కస్ ఇట్ లేట్. రైట్, నెక్స్ట్ క్వశ్చన్ చూడండి. అంతా సింపుల్ క్వశ్చన్ ఇది. సిలిండర్ ఆఫ్ మాస్ m is equal to 2 kg is placed on two parallel rails inclined at an angle of theta is equal to 37 degrees to the horizontal. The side view shown in the figure. A load of unknown mass is suspended from a light inextensible cord wound on the cylinder. The cylinder is held initially at rest and then released. The rolling condition. Idi without slipping. What should be the mass of the road? Okay. Actually, it's comes under rolling, but okay. నాకు మళ్ళీ తర్వాత గుర్తుంటుందా లేదా అని చెప్పి I have picked up this. So what are the free body diagrams? mg, tension, tension. What are the other cases? mg, and remember, mg. నార్మల్ రియాక్షన్ కూడా ఉంటుంది. Normal reaction, right? Now, what point you need to select right now is, this is a center C, this is O. So there is a possibility about this point, you need to balance the torques. అందుకే ఫ్రిక్షన్ సంగతి తీయలే, ఫ్రిక్షన్ ఈ డైరెక్షన్లో వస్తుంది, రైట్? అబౌట్ దిస్ పాయింట్ వాట్ ఆర్ ద టార్క్స్? ఒకసారి చూడండి, ఇది కూడా బార్డరే. దిస్ ఈజ్ ఆల్సో a border based concept. Theta. Theta. So this is R cos theta. So net torque about O0. So what is this? mg is capital mg. Unknown mass got capital. Is mg, capital mg. About this R cos theta. అంతేగా, ఆర్ కాస్ థీటా, ఆర్ సైన్ థీటా. ఆమెకి ఇప్పుడే చెప్పేది సైన్ థీటా. సైన్ థీటా ఈజ్ ఈక్వల్ టు, ఇప్పుడు నెక్స్ట్ ఏంటంటే ఎంజీ టైమ్స్. ఇప్పుడు ప్రాబ్లం ఏంటంటే, దిస్ ఈజ్ ద లైన్ ఆఫ్ యాక్షన్ ఆఫ్ ఫోర్స్ అండ్ యూ నీడ్ టు, దిస్ ఈజ్ ద పర్పెండిక్యులర్ డిస్టెన్స్. ఇదేమవుతుందో నాకు చెప్పగలుగుతారా? ఈ పార్ట్ ఆర్ మైనస్ ఆర్ సైన్ థీటా అవుతుంది, అంతే కదా? అరే ఇప్పుడు ఈ లైన్ ఈజ్ అ డివైడర్, ఫల్క్రమ్ లాంటిది. ఈ లైన్ డివైడర్ అవుతుంది. ఇటేమో ఎంజీ, ఇటు స్మాల్ ఎంజీ. సో దేర్ ఫర్ స్మాల్ ఎంజీఆర్ 1 మైనస్ సైన్ థీటా అయిపోయింది. కండిషన్ ఏంటంటే ఇది 0 కావాలి. సో టార్క్ 0 కావడానికి, సో ఎం మస్ట్ బి లెస్ దాన్ క్యాపిటల్ ఎం సైన్ థీటా బై 1 మైనస్ సైన్ థీటా. ఓకేనా? క్లియరా? సో ఈ రెండింటికి సొల్యూషన్స్ లేవు, మిగతా వాటన్నిటికీ ఉన్నాయి. బట్ కొన్ని క్వశ్చన్స్ నిన్న మనకి కొన్ని ఆగినాయి. ఇప్పుడు ఈ మోడల్ ఉంది, ఇది చేయాలి 1 2 3. ఇది ఇది ఇప్పుడు నేను చేసిన క్వశ్చన్ ఇది ఒకటే, ఇప్పుడు ఇది చేసేసినట్టే. సేమ్ క్వశ్చన్, సేమ్ మోడల్, రైట్? ఇవి చెయ్యాలండి. ఇప్పుడు మనం కొద్దిగా రివర్స్ నుంచి వచ్చి ఐ జస్ట్ క్లోజ్ దిస్. maximum we will close by this session itself. By 9:30 I will close all these questions. చెప్పండి. Figure shows an arrangement of masses hanging from ceiling. The equilibrium of each rod has negligible mass and extends 3 times so far to the right. అంటే see anywhere you can see, anywhere you can see, if this is L, this is 3L, right? So very clear, what is the condition for the, let this be 1.1. At 1, M2GL is equal to M1Z 3L. Very clear, M2 is 3M1. So at 1, what is the mass now? 4M1, right? Now let this be 2. So at 2, you have M3GL is equal to 4m1z 3l. M3 is 12m1, right? Okay, na? So at this point, what is the mass? Totally 13m1. Now let this be 3. ఎంత 15 ఎందుకు? 12m1 plus 3m1. Correct. 15m1. Very good. ఒక్క నిమిషం రా, ఇక్కడ అప్పరెంట్ గా మాస్ ఎంత అంటే 4m1. ఇక్కడ అప్పరెంట్ గా మాస్ ఎంత అంటే M3 12m1 ప్లస్ 4m1 16m1 ఉన్నట్టు. ఇప్పుడు ఎట్ 3 చెప్పండి. ఎట్ 3 ఏం జరుగుతుంది? ఎట్ 3 M4GL is equal to 16m1G3L. GL కొట్టేస్తే M4 is 48m1. నువ్వు M4 48 ఇచ్చావు. So therefore M1 is M4 by 48, which is 1 kg. Nana, Dakshesh, any doubts on this? No, sir. Thank you. Yes, 71. Please go through 71 question. Find the minimum height of the obstacle so that the sphere can stay in equilibrium. మీరు జాగ్రత్తగా నోటీస్ చేస్తే this is the sphere. This is the center of mass. This is the vertical. This condition is satisfied. What happens? We'll talk about this point. Adega condition. Trust me, 2020 IIT question also came on the same. I will discuss tomorrow those IIT questions. That's all. What do you want now? What do you want now? Theta. This is also 90 minus theta, 90 minus theta, theta. And you know this is R. This is R. And this is H. This is R minus H. Okay, na? So what is cos theta? Cos theta from this is R by R minus H. So therefore R cos theta minus H cos theta is R. So H is R times మిమ్మల్ని ఏమడుగుతున్నాడు? మినిమం హైట్. H is R. కరెక్ట్గా రాశానా? నేను ఒక్కసారి అమ్మా మొక్క ముందర చెప్పాలి మీరు. ఎన్ని అయిపోయిన తర్వాత చెప్తారు మీరు. R minus H by R. So therefore R minus H is R cos theta and H is R times 1 minus cos theta. Done. Any doubts? Dakshesh. Dakshesh. Any doubts? Dakshesh, I will come sharply there by 11:30, 12 today without fail. Right. Yes. Work on this. Answer is also available for you. Tell me how to handle this. చెప్పండి ఇది. And you are substituting this part L by 4 and you have weight acting through this point. Right. Now suppose let the tension here be TC and the tension here is a TB. TB is sin alpha. TB cos alpha. TC sin beta. TC cos beta. One thing I can confidently say, it is in horizontal equilibrium. So therefore, confidently, sigma fx is equal to 0. So therefore, TB cos alpha is the same as TC cos beta. Let this be equation 1. I hope there is no doubt till this point. Next, sigma Fi is equal to 0. TC sin beta plus TB sin alpha is mg. Equation 2. Right. You have alpha. So therefore, I will apply about C. Net torque about C is equal to 0, which means mgl by 4 is TB sin alpha times 3L by 4. Correct or not? L by 4, L by 4. So therefore, TB sin alpha can be written as mg by 3. Where TB sin alpha is known. So therefore, TC sin beta is 2mg by 3. Right. Okay. Next, you got already you got a TC sin beta. Right. Okay, no issues. Right. What are unknowns? Beta is one unknown. TB, TC are two unknowns. I could manage. Or since alpha is known, from this, since alpha is known to us, TB sin 30 is equal to mg by 3. Implies TB is equal to 2 by 3 mg. I got TB now. Now you see TC cos beta is TB cos alpha. Now TB 2 by 3 mg cos alpha root 3 by 2. Now you take tan beta now out of this ratio of these two things. అంతేనా? ఏ వస్తుందిరా నాన్న? 2 by root 3 వస్తుంది. సో therefore beta ఏం వస్తుంది? Tan inverse 2 by root 3. Done. Any doubt on this? Pakka? Right. Next. ఇది కూడా అంతే, సేమ్ క్వశ్చనే. ఆయన ఎందుకైనా మీకు ఒకసారి చూద్దాం. ఏ యూనిఫార్మ్ డిస్క్ షేప్డ్ పుల్లీ which can rotate freely about an axis passing through the center. Thread is wrapped. అరే నాకు కొంచెం నాకు అర్థమైపోయింది, అడిగి చెప్పేది వదిలేప్ప. చేసాం కదా ఆల్రెడీ. We have done mg, capital mg. About O, you will equate moments. mg times r sin theta is equal to mg times r. R cancel, z cancel. Small m by capital M is simply 1 by sin theta. A simple question. Any doubts? Dakshesh, any doubts till now? Dakshesh. Clear, right, thank you. ఇది చేసేసినట్టే. ఇదొక్కటి చేస్తే బేసిక్ మోడల్స్ అయిపోతాయి. రైట్. Cylinder of radius r and weight w is pulled against a step of height h, which is actually this is a previous IIT question, if I am not mistaken. By applying a horizontal force F at its center as shown in the figure, the cylinder does not move. Maximum possible value of applied force is. See, geometry is the criteria here. Choose this as your point. W R minus H. This is some X. So for normal reaction to be 0, F into R minus H about this point, O. About O is W times X. What is X? This is R. Okay. This is R. Okay. How to know X? For this purpose, you require theta. So what is sin theta here? Sin theta is R. And the geometry aspect, we have theta. This is R minus H. This is R. This will become R square minus R minus H. R minus H whole square, which will become R square cancel అయిపోతుంది. You will get 2RH minus H square. Now tell me what is X now? F into R minus H is equal to W. What is X? X is R cos theta. F into R minus H is WR. What is cos theta? Cos theta is root 2R H minus H square divided by R. So finally, what is F? W times 2RH minus H square by R minus H. Do you have any doubts on this, boys? Do you have any doubts on this? Pakka. Sure. Right? Next. This is also a very good question. Try this. Dakshesh, confirmation from your side is pending. Dakshesh. Clear? Right. 858. Right. Easy question actually. See, somehow or other you will get these questions. I'm telling you this week, blindly follow these questions. Do once again these questions. Complete assignment. Doing this question doesn't mean writing a social composition. Learn these questions otherwise. You are not compromising now in the process of learning. Are you? Then models or same concept applications is what you will get repeated. Right. Hemisphere of mass M is being pulled by a constant horizontal force F, as shown in the figure. The hemisphere moves with constant velocity while maintaining the inclination theta. Find the coefficient of friction between the hemisphere and the floor. Now, in this case, right. Now you have a floor here. That's the floor. So we have force here. And this makes an angle theta. Remember, this is the center. This is the normal reaction. Because you know normal pass through the center. That is a fundamental rule. Okay, right. That is about normal. That's normal, which passes through the center. And also, your center of mass is here. Center of, what is this hemisphere? We will call this as a C and we will call this as O. We will call this as point P. About C, weight acts downwards. mg. Now try to please understand about P. About P. you can apply because it is moving with constant velocity. It is moving with constant velocity. That's friction, that contact point. See, it is moving with constant velocity. Right. So net torque about O is 0. So what are the forces contributing torque? One is the applied force. So here one thing is clear. Capital F is same as F. Capital F is the same as F. Why? Moving with constant velocity. About O torques. I need to follow this carefully. mg, if this is theta, this is cc dash. Here cc dash is OC sin theta, right? And by the way, if this is a theta, this is a 90 minus a theta, and hence this is a theta, geometry based, right? Sphere కి అంతా 3/8 R. కరెక్టేగా? Right. Yes. About this is R, and this is a 90 minus a theta. So therefore, R ఇది clockwise. ఇది and F contribute anti-clock. ఒకసారి. Weight contributes mgcc dash is an anti-clockwise torque. And rest all about O. What are about O? ఇది ఏం టార్క్ ఇది anti-clockwise. F anti-clockwise. And if this is R, this is R sin theta. This is also anti-clockwise. The only torque in clockwise sense is Fr. Now mg 3/8 R sin theta plus F R sin theta is Fr. In the place of F, you can write capital F. So therefore, F, in other words, can be written as mg times 3/8 mg times sin theta by 1 minus sin theta. Don't forget, F is equal to F, and it is moving, slipping. So therefore, here F is clearly mu mg. Clearly mu mg. So therefore, mu mg is 3/8 mg sin theta by 1 minus sin theta. Mg cancel. You have the same. Mu is 3/8 times sin theta by 1 minus sin theta. What are the silent points in this? It's moving with constant velocity, no acceleration. You can apply torque equation about any point. and it is not having any angular acceleration, it is having pure translational motion. So therefore, I can make net torque equal to 0. Since it is moving with constant velocity, F is equal to F, and it is slipping here. So F is mu n, and n is nothing but mg in this case. Now, please tell me, do you have any doubt in this question? Pakka? Right. Areyar, Dakshesh, confirmation from your end. Dakshesh, I want a confirmation from your end. Clear. Right. Thank you. I have done almost there. One question yesterday I started. I didn't completed it, it seems. This is the one. This is the one which I did not complete it actually. Go through once, please. This is a very, very important model. I think in one of your assignment, you had this question. Just please check. In one of your assignment, you had this question. Here, F1 cos theta plus F2 is equal to, we have actually stopped this question because it happened to be the last question. Kindly please spend some time on the part of the solution which I have done. So with this, F1 is same as F2 because about this point, torques must be the same. So therefore, tau about C is 0, which is F1 is equal to F2. Let this be some F. So F is N1 sin theta by 1 plus cos theta. But you know what is N1? You have derived here. So finally, what you are getting is mg by 2 times sin theta cos theta by 1 plus cos theta. By the way, what is N1? N1 is mg. What is mg here? mg refers to the mass of mg refers to weight of AB. So how do you get mass of the rod? The mass of the rod is, 1 minute. You want AB. Just now you have determined AB. AB you have determined, no? AB is nothing but lambda r cot theta by 2 or lambda r by tan theta by 2. So therefore, I'm giving you the final answer now. What is the final answer? Lambda rg by 2 tan theta by 2 times sin theta cos theta by 1 plus cos theta. So in exam, if you get such questions, one more important time, I think sin theta by 1 plus cos theta అని ఎవరు రాసుకోవచ్చు? Sin theta by 1 plus cos theta కూడా sin theta ప్లస్ 1 ప్లస్ కాస్ థీటా అని tan థీటా బై 2 అని రాసుకోవచ్చు. అవునా కదా? You can write 1 plus cos theta as 2 cos square theta by 2. You can write sin theta as 2 sin theta by 2 cos theta by 2. So therefore, finally, sin theta by 2 by cos theta by 2 left hand side మిగులుతుంది ఆ బాక్స్ లో. దట్ ఈస్ tan theta by 2. సార్ ఎందుకు సార్ అంటే, I just want to restrict it. Lambda rg cos theta పైన denominator 2. Finally, everything is the known terms. I've given you friction. What do you want? Find the frictional force between the ground and the loop. That's all. I've given that. Done. Pakka simple question. Right. Anything else left? 18th question is left. Now you can manage this question. Just now I have done. Now you can manage. The chase previous question is okay for you? Speaking about this one. Dakshesh. Right. Thank you. Now we will complete this. By 9:40, I want to finish empty blanks based situations. There are some pathfinder questions. I already solved some. Writing time tagutundi కాబట్టి we'll close. Right. చూడండి ఒకసారి అందరూ చూడండి. So I want a free body diagram of this arrangement. Right. What are the different four? I don't think this is a new question. Same thing we have done previously. Wedge made the spear. Two questions we have done almost the same today. I'll try to show you. You'll get it. That is the weight capital M, mg, kept on a rough incline of incline. Okay, later release. Small particle of mass M. mg. You take this as your reference point. అయిపోయింది కనుక మీకు ఏం చేయాలో మీకు తెలుసు. when the disc is placed on the incline with its diameter AB parallel, అది ఎందుకు ఇచ్చారో చూసుకోవాలి. ఇట్ స్టేస్ ఇన్ ఈక్విలిబ్రియం. నువ్వు ఏది చెప్పినా నాకు అర్థమయ్యేది ఒకటి. రైట్. ఒక్క నిమిషం ఆగండి. ఇక్కడ అఫ్ కోర్స్ ఫ్రిక్షన్ ఉంటుంది, నేనేం కాదంటల్లా. దట్స్ ఫ్రిక్షన్. మనం అవాయిడ్ చేయడానికి ఏం చేద్దామంటే, అది బైసెక్టార్, వర్టికల్. The significance of this is, since if I refer this point, friction and normal reaction part, friction and normal reaction is both passing through the same point. Now let this intercept here at point P. Now geometry is important for me. This is A, this is B, and this is some vertical. And the information what I know here is This is a 90 degrees. Because this is a normal, kada? And this is point P. Point P, akkada తీసుకున్నానా point C తీసుకున్నా ఇక్కడ. Point C. Clear? Right. No issues. Now the question is, ఇప్పుడు ఇది హారిజాంటల్. ఇది ఇప్పుడు parallel to the inclined plane కదా, కాబట్టి this angle becomes theta. ఇప్పుడు ఇది 90 minus theta. అంటే అప్పుడు ఇది theta. అయిపోయింది. ఇది P. నేను AP ఇచ్చేయగలను మీకు. ఎట్లా చేస్తాను చెప్పండి. AP by AC is tan theta. Agreed? రే AC మనకు తెలుసు R. AC అరే ఇది సారీ, AP అనకూడదుగా అప్పుడు OP OC. OC తెలుసు మనకి. OC is radius. So therefore OP is R tan theta. అమ్మయ్య. మరి నాకు PB తెలుసా? తెలుసు. What is PB? PB is OB minus OP. OB అంటే అంతేనా? ఎనీ డౌట్? R minus R tan theta. అయిపోయింది. అదెవడికి కావాలి? అక్కలమ్మకు. మాకు కావాల్సినవి ఏంటో నేను చెప్పనా? రెడ్ లైన్తో రాస్తాను. ఇప్పుడు రెడ్ లైన్ కాబట్టి బ్లూ లైన్తో రాస్తాను. నాకు ఈ పార్ట్ కావాలి, ఈ పార్ట్ కావాలి. ఇది x1, ఇది x2. ఓకే, ఇది తీటా, ఇది తీటానే. నాకు ఎవరైనా చెప్తారా x1 అంటే ఏంటి? ఇది OP cos theta. అగ్రీడా? x2 అంటే PB cos theta. అగ్రీడా? అబౌట్ P ఏం చేయొచ్చో మీరే చెప్పండి. మరి అబౌట్ ఏ ఏం చేయొచ్చో మీరే చెప్పండి. అబౌట్ ఏ కదా ఇది C. నెట్ టార్క్ అబౌట్ C ఈజ్ 0. అప్పుడు ఏమవుతుంది? mg టైమ్స్ x1 ఈజ్ ఈక్వల్ టు mg టైమ్స్ x2. ఇందులో ఐ హావ్ స్కిప్డ్ నార్మల్ రియాక్షన్ అండ్ ఫ్రిక్షన్. వై? because correct, they are passing through the intersections. Now hold on. ఇప్పుడు ఇదేం రాయొచ్చు? mg x1 అంటే OP cos theta is mg PB cos theta, right? m times OP R tan theta is equal to m times R into 1 minus tan theta. నువ్వు ఫస్ట్ అడిగింది ఏంటో తెలుసా? స్మాల్ m. You asked me about small m and theta ఏమన్నా ఇచ్చావా? 37. తర్వాత సంగతి తర్వాత చూసుకుందాం. Small m is m times tan theta by 1 minus tan theta. Capital M times tan 37, 3 by 4. 1 minus 3 by 4, 1 by 4. 3 times capital M. So I got the relation. So I have done the first part. Any doubts? Ask me now. The entire depth of the solution lies in geometry part, not on the physics part. లేదు సార్ నేను ఇట్లా చేయను, యువర్ చాయిస్. మీరు వేరే పాయింట్స్ ఏమన్నా చేసుకోండి, నాకేం ఇబ్బంది లేదు. రైట్. నౌ యూ నో mg. నౌ ఇఫ్ ఐ అప్లై ది టార్క్ ఈక్వేషన్, నౌ బికాస్ ఇట్స్ ఇన్ ఈక్విలిబ్రియం, if we apply torque equation, About O, what is the situation? About O, torque contribution is 1 due to friction. The other due to mg. And even I know this distance also. Got it? Got it? So now about O net torque 0. Okay na? Hey, మీకు ఎందుకు ఈక్విలిబ్రియంలో ఉంది ఏ పాయింట్ నుంచో నేర్చుకోవచ్చు. నెట్ టార్క్ అబౌట్ ఓ జీరో అంటే అప్పుడు ఎఫ్ ఇంటూ ఆర్ ఈజ్ ఈక్వల్ టు ఎంజీ ఇంటూ ఓబి కాస్ తీటా ఎలవుడా ఓబి కాస్ తీటా ఎలవుడేగా ఒరే తీటా తెలుసు మనకి తెలుసా ఓబి అంటే ఆరు ఎఫ్ ఇంటూ ఆర్ ఈస్ ఎంజీ టైమ్స్ ఓబి అంటే ఆర్ కాస్ తీటా కాస్ 37 4/5. సో ఫైనల్లీ ఇది 4/5 mg. ఓకే, దట్ ఈస్ ద ఫ్రిక్షన్. ఓకేనా? క్లియరా? రైట్, ఇది ఫ్రిక్షన్. ఓకే, అది కాదు మీ ఆన్సర్, గుర్తుపెట్టుకోండి. మీకు ఇప్పుడు నార్మల్ రియాక్షన్ కావాలి, నార్మల్ రియాక్షన్ కావాలి. రైట్, అండ్ ఇది ఎంజీ. రైట్, అండ్ నార్మల్ రియాక్షన్ కావాలి నాకు, ఎట్లా చెప్తారో చెప్పండి. ఎందుకు కావాలో కూడా చెప్తాను నేను మీకు. మ్యూ డిటర్మిన్ చేయాలంటే నార్మల్ రియాక్షన్ కావాల్సిందేగా. రైట్, చెప్పాలి మరి, మీరే చెప్పాలి. ఇప్పుడు ఇది తీటా అంటే ఇది తీటా, నాకు నార్మల్ రియాక్షన్ చెప్పాలి. ఇది ఎన్ చెప్పండి ఒకసారి. ఎన్ ఈజ్ ఈక్వల్ టు ఎంజీ కాస్ తీటా అయిపోయింది. ఈ ఎంజీకి ఇది 90 మైనస్ తీటా, ఈ పార్ట్ 90 మైనస్ తీటా అంటే ఇది కూడా తీటానే, ప్లస్ ఎంజీ కాస్ తీటా. రైట్, నార్మల్ రియాక్షన్ ఏమైంది? ఎంజీ కాస్ తీటా, ఎంజీ కాస్ తీటా ప్లస్ స్మాల్ ఎంజీ కాస్ తీటా. ఇప్పుడే మీరు ఎక్కడో కట్టారు, క్యాపిటల్ ఎంకి స్మాల్ ఎంకి రిలేషన్. క్యాపిటల్ అంటే స్మాల్ m/3, ఇది 4/3 ఎంజీ కాస్ తీటా. 4/3 ఎంజీ కాస్ తీటా అంటే కాస్ 37, 4/5, 16/15 ఎంజీ. ఓకే సార్, ఏం సార్ ఎందుకు చేస్తున్నారు? ఒక్కని షాకు. ఇది నార్మల్ రియాక్షన్. ఎఫ్ లెస్ దాన్ ఆర్ ఈక్వల్ టు మ్యూఎన్, మీకు తెలుసు ఆ కండిషన్. 4mg/5 లెస్ దాన్ ఆర్ ఈక్వల్ టు మ్యూ టైమ్స్ 4/3 mg ఇంటూ 4/5. రైట్, సో మ్యూ గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు 3/4. సో టెల్ మీ వాట్ ఈస్ ద మినిమం వాల్యూ ఆఫ్ mu minimum is 3/4. Any doubts? Please go through the question and tell me. See, there are 3 parts in the question. First part, identifying the relation between small n and capital M. That geometry part plays a crucial role, and I have derived the relation between small m and capital M. Thereafter, I have determined friction. That is the second part. Friction I have determined by applying net torque is 0 about O. Third point, I have determined the vertical component because it is in equilibrium. Along the inclined force components balance, and I got N. So I have checked the condition F less than or equal to mu N. Now please tell me, do you have any doubt in this question? Dakshesh, any doubts? Right. This is also a very famous model. This is also a very famous model. Lifting a rod. అంటే దీంతో రెగ్యులర్ క్వశ్చన్స్ అపార్ట్ ఫ్రమ్ పాత్ ఫైండర్ క్వశ్చన్స్ అన్నీ అయిపోతాయి. లిఫ్టింగ్ ఏ రాడ్ క్వశ్చన్, బట్ బిట్ కాంప్లికేటెడ్. రీడ్ ద క్వశ్చన్ కేర్ఫుల్లీ. Uniform rod is lying on a table. A boy applies a force at its one end so as to slowly lift the rod. He keeps the force always perpendicular to the rod. Thank God. The other end of the rod does not slide and the rod was brought to a vertical position. Determine the minimum coefficient of friction between the rod and the table. Right. So first, try to please understand what is the diagram given. This is the floor. This is the rod. This is the force F. mg. Normal reaction N. See, when you are trying to lift this up, the tendency of this end is leftwards. So to support, friction acts in this direction, F. And this makes an angle theta. This is the diagram. Any doubts? Now, what is that you need to do is you are slowly lifting. And we will call this as a rod AB. You said you are slowly lifting. Right. Now, at this particular instant, it is still in equilibrium. Rod is in equilibrium. Rod is in equilibrium. So now equilibrium means net torque about A is 0. Agreed, boys and girls? Net torque about A is 0. Ventala, Ritvik. Net torque about A is 0. అంటే ఇప్పుడు ఏమవుతుంది? ఫోర్స్ ఇంటూ పర్పెండిక్యులర్ డిస్టెన్స్ ఎల్, ఇది దీని టార్క్, వెయిట్ టార్క్ ఎంజీ ఇంటూ L/2 cos theta. So this gives me a condition that F is mg cos theta by 2. F is a variable force. Maybe you are applying always perpendicular to the rod. Direction wise may be constant with respect to the rod, but magnitude wise it keeps changing. Right. So for vertical equilibrium, sigma Fy 0. Sigma F by 0, what are the upward forces? N is the upward force. And this F will also have an upward component. How do you know that component? Simple. This is a 90 minus theta. If this is 90 minus theta, the vertical component is F cos theta. And the only downward force is mg. Agreed? Okay. Sigma Fi, then sigma Fx is equal to 0. Let this be equation 2. Fx 0. What are the horizontal forces? One is F. The other is F sin theta. Anything else apart from this? Remember, you are slowly lifting that. Equation 3. Okay, I have drawn the data. What do you want basically? The minimum coefficient of friction. Didn't get you. What do you mean by that? Define what is, how they are related. So how they are related? How they are related? Color change. They are related as you want a condition like this. So long the friction is static, I have no issues. It won't slip at A, at end A. So therefore, F sin theta less than or equal to mu into normal reaction is what I want. Normal reaction is F cos theta. You know F, substitute the value of F. You just substitute the value of F. So you will get the condition finally mg cos theta sin theta by 2 less than or equal to mu times ఇంటలేదురా ఈ క్వశ్చన్స్ చెప్పకూడదు mg cos square theta by 2. Solve చేయండి. You will get one condition in terms of mu. So you will get a condition mu greater than or equal to, trust me, 1 by already solve చేసింది ఇది నేను 2 tan theta plus cot theta. That's what I got. If you don't trust me, check it. So now you want a minimum condition. So you want the maxima of this function 2 tan theta plus cot theta is equal to 0. 2 secant square theta minus cosec square theta is equal to 0, which means cot square theta is equal to 2, which means tan theta is 1 by root 2. Agreed? Right. Okay. Now just substitute mu minimum is 1 by 2 times 1 by root 2 plus root 2. So this is nothing but 1 by 2 root 2. That's all. A very good question. Let me check whether I am right or not right. Correct. Mu minimum is 1 by 2 root 2. Okay. So most of the cases I have solved. Right. All these questions are Pathfinder questions. Remember, from here, regular questions I have solved. All regular questions I have solved. Only Pathfinder questions are left. I'll try to do 1 or 2 questions now. 1 or 2 questions tomorrow. Now, this is the complete form of the notes for you. I'll post it right now. Right. A rigid body is observed in equilibrium. Okay. Go through the, it's a theory question. Try to answer this. A pure theory question. Try to please answer this. I'm just checking any other questions left pending. A rigid body is observed in equilibrium in a particular, the problem is non-rotating, non-inertial frame. Non-rotating, and it has some acceleration. Non-rotating, but it is an non-inertial frame. It is under acceleration, right? What can you conclude if the body is observed from an inertial frame? See, basic understanding is it's in equilibrium means in a non-inertial, for example, you take an example like this. You take an example like this. I'm taking a very simple example. Right. Now this is experiencing an F force whose mass is M. That's all. And it's passing through F. So it won't give any rotation part. So therefore, acceleration of center of mass is F by M. Suppose if an observer moving with the same acceleration, then for me, the rod will experience 2 forces. One is F, the other is also F, which you will call as pseudo force. Tell me what happens. In your frame, with respect to him, rod is in equilibrium. With respect to ground, rod is having acceleration. Now tell me, the body is in rotational equilibrium, but not in translational equilibrium. Option A is correct, because the proof I have given. Next, net torque of all the forces on the body about its center of mass is a zero vector. Correct kada? అప్పుడే కదా రొటేషన్ ఉండదనేది చెప్పేది. నెట్ టార్క్ ఆఫ్ ఆల్ ద ఫోర్సెస్ ఆన్ ద బాడీ అబౌట్ ఇట్స్ సెంటర్. అది యాక్చువల్గా బీనే నాకు హింట్ ఇచ్చింది ఏ చేయడానికి. నెక్స్ట్ సి, నెట్ టార్క్ ఆఫ్ ఆల్ ద ఫోర్సెస్ ఆన్ ద బాడీ అబౌట్ ఎనీ పాయింట్ దట్ ఈస్ కొలీనియర్ విత్ ద లైన్ ఆఫ్ యాక్సలరేషన్ ఆఫ్ ది మాస్ సెంటర్ ఈజ్ ఎ జీరో వెక్టర్. అంటే సి, ఇన్ ది ప్లేస్ ఆఫ్ జీ యూ అజ్యూమ్ ఏ. ఫర్ ఎగ్జాంపుల్ మనం చాలా కేసెస్లో ఏం చేసాము? ఫర్ ఎగ్జాంపుల్, ఐ జస్ట్ వాంట్ టు షో యూ దిస్ కేస్. మీకు గుర్తుంది కదా, మనం ఏం చేసాం? మనం ఏం చేసామండి? ఈ లైన్ కనుక ఉంటే టాపులు అయిపోద్ది, అదే కదా మనం చెప్పింది. మనం ఈ లైన్ తోటే కదా కంపేర్ చేసింది ప్రతిదీ. ఇప్పుడు నీకు జీ లేదు, ఏ తీసుకో, యాక్సలరేషన్ ఆఫ్ ద ఫ్రేమ్ తీసుకో. ఫర్ ఎగ్జాంపుల్, నీ ఫ్రేమ్ ఇలా వెళ్తుందండి విత్ అన్ యాక్సలరేషన్ ఏ అనే హారిజాంటల్ ఫ్లోర్. హారిజాంటల్ ఫ్లోర్. ఇప్పుడు నీ ఫ్రేమ్లో ఇది ఎంఏ అయితే టాపులు అవ్వదుగా? అవుతుందా అవదా? అవ్వదు. ఎందుకు కాదు? యాక్చువల్గా ఇక్కడ రెండు ఫోర్సులు ఉన్నాయి. ఒకటి నార్మల్ రియాక్షన్ ఫోర్స్, ఇంకోటి ఫ్రిక్షనల్ ఫోర్స్. రిజల్టెంట్ ఫోర్స్ ఎట్ యాక్ట్ అవుతుంది, ఇట్ యాక్ట్ అవుతుంది. రిజల్టెంట్ కాంటాక్ట్ ఫోర్స్. నువ్వు త్రూ సెంటర్ ఆఫ్ మాస్ యాక్ట్ అవుతుంది రిజల్టెంట్ కాంటాక్ట్ ఫోర్స్. సి, ఒకటి సూడో ఫోర్స్ పాసింగ్ త్రూ center of mass. Resultant contact force is also passing through center of mass. In this case, what is happening? It's in rotational equilibrium. So net torque, all the forces on the body about any point that is a నిన్న 3 days back కూడా చాలాసార్లు చెప్పించాను మీకు. కండిషన్ ఫర్ ఈక్విలిబ్రియం అంటే యూ షుడ్ ఫైండ్ సమ్ ఇంటర్సెక్షన్ పాయింట్. సో దట్స్ హ్యాపెనింగ్ ఓవర్ హియర్. ఎనీ పాయింట్ on the body about any point that is collinear with the line of acceleration of center of mass is a zero vector. Null vector and a zero vector. A very, very important question. Multi correct answer type questions. You can expect such questions. Okay. Dakshesh, any doubt? Dakshesh. Right. Thank you. Only one question is pending without a solution. I'll complete this. With this, you will have a complete notes. చూడండి, ఇది వెరీ రిపీటెడ్ క్వశ్చన్. అంటే మన వాళ్ళు ఏంటంటే ఇక ఎంత అలవాటు పడిపోతారంటే ఆల్మోస్ట్ ఈ క్వశ్చన్ ఏదో స్టేజ్లో మీకు ఇంక నుంచి తగులుతుంది. నేను ఇమ్మీడియట్గా రేపు జరిగే ఎగ్జామ్లో జరుగుతుందని నేను అన్నాం. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ మీరు క్యూములేటివ్లో తగలటల్లా కొన్ని క్వశ్చన్స్ పాతవి అట్లా. నేను రిపిటేషన్స్ అవాయిడ్ చేస్తాను ఎక్కువగా. I will avoid repetitions. I'll select different models. But whatever the questions that they pick may be from these models only. Right, go ahead. Light beam suspended with the help of two ropes supports two loads. Yeah, shown in the figure. Right. You can see that. The maximum tension that either of the అరే ఇక్కడ నెక్స్ట్ పేజ్ అంటే వాడు నెక్స్ట్ పేజీలో చూపించాడు వాడు. మనం ఏంటంటే ఇక్కడే పేస్ట్ చేస్తాం కదా. అలా మీరు తర్వాత పేజీలో ఏదో ఎదుర్కొంటారు. The load at the left end is of 75 kg and that at the right end is at P at the right end is unknown. The maximum tension that either of the rope gets, this is a very important statement. Right. What if, suppose లైట్ బీమ్ అండి, అది కూడా గుర్తుపెట్టుకోండి. లైట్ బీమ్. సో ద బీమ్ ఈజ్ మాస్లెస్. Now, for example, I will take the first case. We will take always this as a T1 and we will take always this as a T2. Case 1. Right. You are not restricting me about tensions kada. Maximum tension ke restriction undi. So minimum tension a T2 anta kavatsu. See, I'm just assuming one situation where T2 is equal to 0, for example. If T2 is equal to 0, then what happened? 75 into Z into half is equal to MP into Z into 2.25 plus 0.75, 3. Right. So, ఇప్పుడు Z calculate MP is equal to 25/2, which is nothing but 12.5 kg. Correct. Okay, next case వచ్చేసి maximum tension, maximum mass కి ఇక్కడ maximum tension కేసు తీసుకుందాం. రైట్. నేను ఎప్పుడు అబౌట్ ఈ 1 వేస్తూ ఉంటాను, నెట్ టార్క్. అప్పుడు దాని సంగతి మనకు అనవసరం కదా. కేసు 2 ఏంటంటే T2 tends to 1200 newtons. ఈక్వేషన్ ఇలా రాశానంటే దాని అర్థం టెన్స్ టు. ఇప్పుడు మళ్ళా 75G into 1/2. ఇది క్లాక్ వైజ్, ఇది క్లాక్ వైజే, ప్లస్ 1200 into 2.25 is equal to MPG into 3. ఓకేగా రిలేషన్. సో ఈ కేసులో మ్యాక్సిమం వస్తుంది. సో దిస్ మ్యాక్సిమం టర్మ్ వచ్చేసి 75లో హాఫ్ అంటే ఎంత? 37.5 ప్లస్ ఈ జీ కూడా తీసేసేయండి. అంటే 120 into 2.25 మొత్తం చెప్తున్నావా? 120 into 2.25 చెప్తున్నావా? ఎంత? 270యా? పక్కానా? నిన్న మెసేజా? 270 డివైడెడ్ బై 3. ఇప్పుడు ఇది ఎంత వచ్చింది? 307.5/3. ఇది 102.5 kg. ఓకేనా? అదైతే బి కరెక్ట్. ఇప్పుడు విషయం ఏంటంటే ఇక్కడ దాకా అందరూ చేస్తారు, మీతో అయిపోతాయి. మీకు కనీసం చేయాల్సింది ఏంటంటే ఏబి అన్న మనం ఎన్కాస్ట్ చేసుకుంటే 2 మార్క్స్ వస్తాయి కదా. When mass of the load P is a minimum, the tension in one of the rope vanishes. అమ్మాయ కరెక్ట్. When the mass of the load P is maximum, tension in one of the rope vanishes. Wrong. అవ్వదు. మీరు నన్ను నంబరు, నాకు తెలుసు ఆ విషయం. టోటల్ డౌన్వర్డ్ ఫోర్స్ ఎంత? 750 ప్లస్ ఈ మ్యాక్సిమం వేస్తే ఎంత? 1025. ఇది టోటల్ డౌన్వర్డ్ ఫోర్స్. టోటల్ అప్వర్డ్ ఫోర్స్ ఏం కావాలి? 1200. ఇప్పుడు మీరు చెప్పండి, 1025కి 750 యాడ్ చేస్తే 1775 వస్తుంది. ఇప్పుడు చెప్పండి, T1 నాట్ ఈక్వల్ టు 0నే కదా. సో కాబట్టి D రాంగ్. D is wrong. Okay. So now just hold on. Thin uniform rod AB of mass 1 kg moves translationally with an acceleration A is equal to 2 meters per second square due to two anti-parallel forces F1 and F2. The distance between the points at which these forces applied is equal to 0.2. See, remember it is in rotational equilibrium, not in rotation, but it's a translationally moving. No idea in which direction it is translationally moving. We will assume F2 minus F1 is 1 into A, which is nothing but 2 Newton. Rod 1 kg, acceleration 2 meters per second square. Right. And one more important point, you have given F1 as 8 Newton. So F2 is 10 Newton. Right. Now, please try to understand. Now, I am assuming this is a center of mass. You are experiencing one force F1 like this. And the other force must compulsorily act like this. Suppose if this force acts below, what happens? Net torque won't be 0. And you said that this distance is 0.2 meter. And obviously this distance will be L by 2 minus 0.2. Okay. So about the center of mass, net torque must be 0. F2 times L by 2 minus 0.2 is equal to F1 times L. L by 2. Correct? Na? Net torque 0 చేశారు. F2 10. 10L by 2 minus 2 is 8L by 2. So this is L, which is nothing but 2 meters. That's all. A very standard question. In fact, this is an irido question actually. Right. So I have done. So most of the basic questions, level 2 questions, level 3 questions are also done from my side, this side. And one more important point, see, these questions, particularly, I have done this, I didn't do this one. Let me count questions which I haven't done. 1, 2, 3, 4, 5. I have done this 6. That's all. Only 6 questions were left from my side. Therefore, ECL students, when the time ends, you can leave to your class. I'll keep teaching this. You can go through in the video part, last part. That's it. Can you please respond? Right. Next. So therefore, I'll try to cover some of these models already available for you. You have a cylindrical pipe of radius r and mass m, which is placed vertically on a horizontal floor. Two identical spheres, each of radius r and mass m, are inserted into the cylinders as shown in the figure. I want the radius of the, radius of the spheres is more than 0.5. That's one information. What minimum value of small m by capital M will the arrangement topple? There is no friction between the spheres and between a sphere and the inner wall of the cylinder. Remember, ఇదంతా కూడా గ్రౌండ్ మీద ఉంది. ఇది ఓన్లీ పైపే, సైడ్సే ఉంటుంది. టాప్ అండ్ బాటమ్ ఆర్ ఓపెన్, రైట్? Now, if you see for cylinder alone, what are the forces? One is a normal reaction force N1 here. The other is a normal reaction force N2 here. That's all. And remember, net horizontal force must be 0 on this. So therefore, N1 must be same as N2. Because cylinder purpose, net horizontal force is 0. The cylinder is experiencing two forces, N1, N2, net horizontal force is 0. Now, one more important point is, for cylinder, if toppling happens, it happens about this point. Now, about this point, I am applying torque. Of course, your force is N1. Remember, I am taking this as a small r, and this is 2r. So, this is a 2r sin theta. So, N1 times 2r sin theta plus r is equal to, about this point, torque, N2r plus overall system, the weight of the pipe. Somewhere here it will be there, and that is mg. mgr. Remember, torque of this, torque of this, torque of this. Taken. నువ్వు వింటలేదురా, గోల్డ్ కర్మగా పోతే చెప్తున్నారు. ఇంటల్లా, సీరియస్గా వింటల్లా, రైట్? So finally, of course, N1 is same as N2. So you can get rid of these two terms. Finally, you got N1 times 2r sin theta is mgr. Right. అక్కడ ఆగు చెప్తాను, ఇక్కడ ఆగు. రైట్. ఇప్పుడు దీని ఫ్రీ బాడీ డయాగ్రామ్ తీసుకోండి. ఇది యాక్షన్ కదా, ఇది రియాక్షన్. వెయిట్ and inter contact వల్ల వచ్చే నార్మల్ రియాక్షన్. I have applied Lami's theory. N1 by sin 90 plus theta cos theta, mg by sin 180 minus theta sin theta. From this I got N1. I have substituted that N1 over here. I have substituted this N1 part here. That allows me 2r mg, actually 2r mg cos theta is equal to mgr. So finally you got 2 times like this. So therefore small m by capital M is r by 2 times capital R minus small r. Any doubts? Pakka. So same toppling question. Same toppling question again. Any doubts? Sure. Next. This is also a very important model. This is also a very, very important model. Now, please try to go through this once. A small block is released on the top of the wedge that is placed on a horizontal floor as shown in the figure. You have mass of the wedge being capital M and angle of inclination of its slant surface is theta. Friction between the wedge and the floor is sufficient to prevent sliding, and the coefficient of friction between the wedge and the block is mu. Right. What should be the mass of the block be so that the wedge will not topple? So topple chance, in case it exists at this point itself. The moment as it comes down, you won't see any toppling effect. The first toppling effect, if possible, it is possible at this position itself. Now you have that object here and its weight mg acts in this direction. Suppose if topple happens, normal reaction will act through this point, and this is mg. Right. Now the question is, now somewhere you should see this weight of the wedge, center of mass acting through this point, and you have friction. Friction. F acts like this, and the normal reaction. Remember, I am drawing completely the free body diagram of the wedge, not the block. Right. Now the question is, about this point, what are there? Now, you know already, if in case of a triangle, if its height is h, base is b, okay, the location of the center of mass from this end will be b by 3, h by 3. Already I have given you that proof. So mgb by 3 plus, right, friction, which is acting in this direction. Okay. How to identify the perpendicular distance? Friction is acting in this direction. This is B. So what is going to be this part? Where this is B, this is the perpendicular distance. Okay, right. If this is H, you draw a perpendicular here. If this is H, okay, this is theta. This is H. So obviously, what is this going to be? You want this perpendicular distance, kada? This is H cos theta. Agreed? Right. So perpendicular distance is H cos theta. Friction into perpendicular distance. Mu mg cos theta into H cos theta. You got the same cos square theta into H. Remember, weight anti-clockwise. Friction anti-clockwise. Right. Now, only clockwise part is the normal reaction. That is perpendicular to this line. Okay. So in that case, this is a line of action of force. Now you need to draw an angle here. See, try to please understand. If this is H cos theta, this is H sin theta. Yes or no? But yeah, this is H cos theta already taken. So what is going to be this? H sin theta. Therefore, I have taken that. So mgb by 3 modified because n is mg cos theta. ನಾನು ಅಂತೆ kada normal reaction is mg cos theta on the block. So I got this relation finally. So mg by 3 is equal to mg by 3 is equal to mg. I'll write this properly here. So small m is capital M by 3 sin theta into sin theta minus mu cos theta. That is the mass required to topple. If your mass is more than that part, right-hand side part, toppling will take place. So long the mass is less than the right-hand side part means this part. There won't be any toppling. Any doubts? Right. Very good question, actually. Really, really very good question. Next. 1, 2, 3. And the 3 cover చేయాలి. At least I'll try to cover 2 today. A structure consisting of 2 identical square plates of side L is equal to 40 centimeters hinged to a common axle. You can see the common axle here. This is the common axle. That is a common axle. There is no friction between the cylinder and the plates. At what angle with the vertical will the plates lean in equilibrium? అంటే theta ఎంత అని అడుగుతున్నాడు. So only left plate తీసుకోపా. And that's in equilibrium. ఓన్లీ లెఫ్ట్ ప్లేట్ తీసుకున్నారు అనుకోండి, దాని ఫ్రీ బాడీ డయాగ్రామ్ ఎట్లా ఉంటుంది? ఓన్లీ లెఫ్ట్ ప్లేట్. ఎంజీ normal reaction acts at this point and this is O. And already you know, because you accepted that this is theta, this is L by 2, so this will be L by 2 sin theta. And one more important point, from the geometry part, that's the center, and this is 90 degrees. That's the center, and this is 90 degrees. Angle is 90, and this is theta. Abhaya, this is R. So obviously, what is this going to be? R cot theta. Now about O, NR cot theta is in clockwise sense. Mg L by 2 sin theta is in anti-clockwise sense. I have equated both. From this, okay, this is one equation. This is one equation, equation 1. Now again, for the same rod, take sigma Fi is equal to 0. Remember, if this is a theta, okay, if this is a theta, this is a 90 degrees. This is theta. Geometry, geometry 9. So therefore, n sin theta upwards is mg. This is for the left rod. So you got one more equation. Let this be equation 2. So from 1 and 2 we have finally one equation like this. So which is 2 sin square theta minus cot theta 0. Are you do some nonsense calculation finally. You'll get some not quadratic, a cube root. So with this you will get 3 options. One theta 45. The other cot theta is equal to -1 plus or minus root 1 minus 6 by 2. Remember, this is going to be imaginary. So not possible. Not possible. So only possibility is theta is equal to 45. Any doubts, boys and girls? Sure? Paka? Right. The same situation in the ide question, idi vere question. Both are same, it seems. Right. Now, in this case, what is happening is this is fixed. Fixed. In this case, they are fixed and this is suspended in between. So what is happening? Arey, fatafat, I'll take it out. Fatafat, I'll take it out. See, the upper edges are two identical uniform planks, each of mass, heavy masses there. 87 kg and length L is equal to 1 meter are hinged to the horizontal axis, affixed to the ceiling here. Ceiling. right? Cylinder of mass m is equal to 20 kg, radius is equal to 0.3 meter, is inserted horizontally between the planks as shown. The cylinder touches the planks at a distance. Eta is equal to 0.75 times the length of the plank, eta L. Right. Find the range of coefficient of friction between the planks and the cylinder to keep the system in equilibrium. See, try to see, this is free body diagram, FBD of left plank. And this is FBD of cylinder. Right. Now, I have just taken the data. Actually, 0.75 times the length of the plank. So weight acts like this because 0.75 is more than half. Kabatti, weight of the rod acts like this and contact is happening over here. So the normal reaction is like this. Right. Now, net torque about O is equal to 0 for plank. N times eta L is equal to mg L by 2 sin theta. Also, there are frictional forces too. There are frictional forces too. Now, there is a frictional force also here in this direction. Right. Now, see, for this is a sigma Fi 0 for cylinder. Obviously, 2F cos theta is upwards, weight mg downwards. Normal reactions are acting like this. So 2n sin theta downwards. See, I'm just taking sigma Fi 0 for this. So I got two equations here. One sigma Fi 0 for cylinder, sigma T naught is equal to 0 for plank. So now in this, I will eliminate. I got n from here and I'll substitute this n equation 2 in equation 1. I got 2F cos theta is mg plus, remember there are two terms. This is capital M, mass of the plank. Here this is mass of the cylinder. And don't get confused. So I have substituted, I got the value for friction totally. This is the total value of friction. Okay, what do you want? So the condition which I need to check is F less than or equal to mu n. That I was checking over here. That's all. So I'll get a range for mu. I'll just get a range for mu. Okay, na? Clear? That's all. So maximum I have done, and only this question is left, which I will discuss tomorrow. Tomorrow I will discuss completely previous IIT questions. Okay? Right. And I'll post these notes now only.